In the previous video, we figured out what our endpoint was given a midpoint and one of the endpoints. So what I want to do now is I want to prove to you that segment CM is the same length as segment MD. So let's write down the information we know. So I know point C is at -5, 7. And I know M is at -2, 1, and I know D is at 1, -5. So I want to know the length of CM. If I don't put any symbol over it, that means the distance, and I want to know the length of MD. So those are the two things I need to figure out, which means I am going to use the distance formula. So the way I'm going to write it is I'm going to say the distance of my segment CM is equal to the difference, that's x2 minus x1 squared, y2 minus y1 squared, and we're going to take the square root. So I'm going to say that this is x1, y1, x2, y2. And then I just have to substitute them in. So again, I'm going to stress x's go with x's and y's go with y's. Okay, so it's very important that you keep those two things together. So what do I have? -5, well, x2 I said was -2. It doesn't really matter as long as you're consistent. -2 minus -5. So remember that minus is a part of the formula, squared, plus y2 is 1, minus y1 is 7, squared, and then we're going to take the square root. I'm going to write CM there. So the distance of CM, well, a minus is a plus, so this is the same as -2 plus 5 all squared, which then gives me 3 squared, and this gives me -6 squared. So that means the distance of segment CM is the square root 9 plus 36, so the distance of CM, 9 plus 36 is 45. Okay, so now that I've done that, let's go ahead and do the other side. So what does that mean? We're going to do MD, which is these two. Remember, x's go with x's and y's go with y's. Okay, so since this is already labeled x2, y2, I'm going to make this x1, y1. Because it's a different equation, I don't need to worry about that. That was just to help me with labeling and figuring things out. So on this one, and I wrote a little bit too big, I'm going to say that the distance of MD, so I want to distinguish between this segment and this segment. That's why I give it a last name. And remember, I'm going to put my x's first, and then my y's, and then I'm going to do the square root. Okay? So the difference of my x's and the difference of my y's. X's go with x's, y's go with y's. So here I have -2 minus 1. Here I have 1 minus, and then I have a -5. So that means then the distance of segment MD, well, this becomes -3 squared, and this becomes 6 squared. Ah, very similar, right? This looks like there's a negative there, but it's not. It's just got smudged. So that means my distance of MD is equal to the square root. Negative 3 squared is 9. 6 squared is 36. So the measurement of segment MD is the square root of 45. So I just proved that the length of CM is equal to the length of MD. The other thing I can say is segment CM is congruent to segment MD. So I just proved that this is the midpoint, this is the other endpoint, because this segment and this segment are equivalent.